Hi, how's it going, everyone? Today I'm going to be going over 10.17 on the homework. All right, so what we have here is we have an inverting amplifier, and we assume that the gain is infinite and that the output resistance is equal to 0. So we're asked to find an expression for Cin in terms of A and C. Well, first we can start with the input admittance at this node. Admittance is just 1 over impedance. So 1 over impedance, which gives us the current over the voltage. So performing nodal analysis at this node right here, we have SC times VI minus Vout all over the input voltage. So doing some more algebra, we can rewrite, we could rewrite the expression on the right. We could substitute in A because that's just Vout over the input voltage. And we're left with something like this. Now, I personally, I'm not too fond of admittances. I always like to work in terms of impedance. So if this helps some of y'all, the input admittance is equal to 1 over the input impedance. And when you divide by S, you have 1 over the impedance times, or also divided by S. S is just J omega, and 1 over Z J omega is just equal to capacitance. So we have Cin is equal to S times C times 1 plus A. And that is our expression for the input capacitance. On the other side, I have part B. In part B, we're asked to find the transfer function. So in that case, that's going to be Vout over V sig. All right, so this little diagram over here kind of helps me visualize what I'm solving for. And we're supposed to solve for the transfer function Vout over V sig. We can start with Vi. If you notice on the left, it's kind of like we have a voltage divider here, which is exactly what we're doing. So I'm going to work in terms of impedance. So you have Zc over Zr plus Zc times V sig. Like I said, just like a voltage divider. And this could be rewritten. Impedance could just be written as 1 over Cin times S. And then on the bottom, Zr, well, it's purely resistive, so it's just going to be the R sig. And then we have plus 1 over Ci times S. Just another way to write the impedance of Z. And this whole thing is multiplied by V sig. And what I did over here is you multiply both sides by S times the input capacitance, which will make this term go to a 1. This term will also go to a 1. So on the bottom, we have the input voltage is equal to 1 over S times R sig times Cin plus 1, because that's where we get the 1 from, all times V sig. And with some more substitution, we know that A, or the gain, is equal to Vout over Vin. So solve for Vin, we have Vout over A. Vout over A over V sig is equal to 1 over S times R sig Cin plus 1. And then finally, just moving the A to the other side, multiplying both sides by A, we have Vout over V sig, which is equal to A over S times R sig Cin plus 1. Thank you, everyone. Let me know if you have any more questions. Take care. Bye.